Okay, so for the second day of week 3, we're going to really talk about nutrient classification, or nutrients, so like carbs, proteins, fats. We're also going to talk about vitamins, minerals, and water, and a little bit about how they can affect performance. I will warn you that this particular day we might have the total lectures might be a little bit longer. I get into a little bit more detail doing class this way than I would if we were actually just sitting down in a typical lecture format. So for this video, these are the things that we're going to go through. So we're going to just talk about basic classification, and then we're going to jump into carbs. All right, so to start off, there are 6 classifications of nutrients. Okay, and we can break these down into macro and into micro. So with the macro, we've got carbohydrates, fats, and proteins. And the reason they're called macro is because we need relatively large amounts of these to function. Then we've got the micronutrients, and these are the things where body needs small amounts. So those are the vitamins and minerals. And then we've also got water, which you can make the argument isn't a nutrient per se. We don't get energy from it, but it's definitely essential. So let's just jump right into carbohydrates. Well, what makes something a carbohydrate? Well, carbohydrate is essentially a sugar, and we can classify these a few different ways. We can classify these as a monosaccharide, which is just a 1-unit sugar. Okay, so think of it like kind of chain links. So if it's a monosaccharide, it's like an individual chain link. And so there are 3 types of monosaccharides: glucose, fructose, and galactose. Okay, glucose is the one that we talk about most often. Okay, and when we talked about glycolysis, we talked about glucose. Then we've got disaccharides, so now we've got 2 chain links attached, and these 2-unit sugars are made up of some combination of glucose, fructose, and galactose. And so we've got sucrose, we've got lactose, and we've got maltose. And then we've got polysaccharides, and all these is now we've just got a big long chain. And so with polysaccharides, we can break them into fiber versus non-fiber. Okay, so fiber that we have a hard time breaking down versus non-fiber. So think starch. All right, now carbs are awesome, and like when I did this lecture last semester, Trevor was talking to me about it and gave me some feedback. And like he said, carbs are the greatest part of our diet. And there's a couple reasons why it's so great. One, it's great because they taste good. I love carbs. I love pasta. I love bread. I love all the sugary snacks, that sort of thing. But another reason why so much of our diet comes from carbs is because they're relatively inexpensive, right? Just think of what you can do with a bag of flour and a couple of other things, right? A big 25-pound bag of flour, I think right now at Costco costs something like, or Sam's Club costs like $7, and then I get a bag of sugar for $5 or $6, and I can do a lot of things with that. Now, not just with sugar and flour, but with that as my base, I can make all sorts of delightful treats. Okay. Now, when it comes to the function, as we've talked about before, carbs are used during high-intensity exercise. We also use carbs for fat and protein metabolism. We store carbs as glycogen, and it can also be a source of energy for our nervous system. Okay, so these are just kind of some of the basic things, but we use this during high-intensity exercise. We can't really do high-intensity exercise without carbs because it takes a little too long for fats to be broken down. Now, I want you to look at this figure here, and we'll probably talk about this in class a little bit more, but what do you see? So let me orient you. I should orient you, then ask you the question. But on the x-axis, we've got time. On the y-axis, we've got the amount of glycogen in the body. Wherever we've got these green squares, that just meant that we worked out for 2 hours. So this is high-intensity training, okay, for 2 hours. The blue line is a high-carbohydrate diet. The red line is a low-carbohydrate diet. Okay, now this isn't necessarily a magic number, but it's not completely linear like that. If we did this with a 50%, we would see lines that were kind of in between, and the 60 would be higher than the 50 but lower than the 60. There's a threshold. Okay, so 70 is better than 40, but 90 wouldn't be that much better than 70. Okay, in other words, your body, like we talked about, your body wants to be efficient, and it's going to take in what it can use, but after that, it's like, yeah, this isn't going to help me that much, so why do I need it? Now, getting back to this figure, what do you see here? So what's happening to glycogen after training in each of these situations? So what you can see is that a 70% diet based on this study was enough to replenish glycogen stores. Person became depleted, or the people became depleted after the 2-hour exercise bout, but they're able to replenish, decrease, replenish, right? There's a slight decrease, but it's not like what this person was undergoing, the low carbohydrate diet, where they had a big decrease and then a tiny increase. Okay, and even, over the course of 2 days, big decrease, small increase. Okay, and so their glycogen stores are severely depleted after 72 hours and 3 exercise bouts. So now let's do another one. Again, I apologize. I don't know why this is collapsed like this. So this says initial muscle glycogen. So how much glycogen do we have to start off with? And what's happening with time to exhaustion? So we've got 3 different diets here. And this exercise was done at 75% of max. So basically, working at 75% of your VO2 max, or your maximum aerobic capacity, how long could you exercise? And so people with a low-carb diet, not very long. I mean, it's an hour, so that's a while. But people with a high-carb diet, they're going 3 hours. So a huge difference. Okay? So generally speaking, when it comes to athletes, carbs are where they use or where they get their energy from. And then if you're an endurance athlete, so like marathon runner, more of your fuel is going to come from carbs. Now, like it says here, the amount of carbs is more important than what percentage of your diet. And we're actually going to talk about this also with proteins, is that think about it in terms of proportion. Well, you need so many grams of carbs for every kilogram of body weight. Okay, and then it also depends on the type of training. So if I'm doing high-intensity training, I need more carbs because that's what we burn during high-intensity training. So I got one more figure for you, I think, with carbs. Nope, I'm sorry, I lied. I've got at least 2. This one and one more. So on this one, we've got exercise intensity, so 150% of max versus 31% of max. And we'll get into how you can actually exceed 100% of your VO2 max later. But what's happening to glycogen stores? And so, again, concentration on the y-axis, time on the x-axis. If I have high glycogen stores, but I'm at low-intensity exercise, I'm not actually burning that many carbs. Okay? But if I have high-intensity exercise, obviously it's not going to last very long, but look at what happens to my glycogen stores. It really decreases. And so the amount of glycogen is related to exhaustion in moderate and high-intensity exercise. Okay, here we're depleted, these last 4. We're really not depleted with the 30%, but we definitely are with the 64 and higher. Okay, and then the higher the intensity, the faster we go through glycogen. So, right before a race, should I pound a bunch of carbs? And when I'm saying right before, I'm talking like within 2 hours before. Or I guess this one actually has, 45 minutes. I forgot that's on here. So 45 minutes before an exercise bout, should I eat a bunch of sugar, a bunch of carbs? Okay, and so what you see here is, in this case, on the blue line, the control group, they didn't take in any sugar. And notice that at the start of exercise, blood glucose goes up a little bit and stays relatively constant until exhaustion occurs. Okay? Whereas in the person that they took in sugar or glucose before they exercised, 45 minutes before, they had a spike in glucose. And then almost immediately after they started exercising, they had a huge reduction. And it slightly increased, but it really it never made it back even to normal when exhaustion occurred. Okay, exhaustion occurred earlier in the people that took had glucose supplementation, or whatever you want to call it, pre-exercise sugar feeding. Okay, well, why did this happen? And the reason is when you take in a lot of blood glucose, that causes insulin to be released. And with insulin being released, that opens channels so that you can take sugar into your muscle cell. We've got a huge gradient, and so it's easy for that glucose to get into your muscle cell. Okay, and so as a result, you end up with a lower than normal blood glucose. And this can lead to exhaustion. All right, so this really is the last figure of the slides here. So we've got glycogen concentration on the y-axis, and what we've got here is what happens when you ingest carbs immediately after exercise and what happens if you eat carbs 2 hours after exercise. And so notice that initially glycogen production, sorry, that's what synthesis means, is really high in the people that ate carbohydrates right after exercise. That shouldn't be a surprise. I've got an abundance of glucose, so I'm going to store some of that. I'm going to produce a lot of glycogen. But then over time, the rates are similar. So this leads to carbohydrate loading. And I gave my daughter a hard time this year because they would always go have a big pasta dinner right before her cross-country meet, like the night before. And I'm just like, oh my gosh, me being annoying, saying it's not doing a whole lot. Kind of the old school mentality was don't eat carbs until right before your race and then eat a whole bunch. Okay? Well, what we found is that if you just eat carbs consistently throughout training, you're going to get the same effect. Okay, so but eating a whole, I would make the argument that eating a big bowl of pasta the night before a marathon isn't necessarily going to make a huge difference. Okay, so when it comes to excess carbs, well, we first store it as glycogen, and if we've filled up all the, the storage space that we've got with glycogen, then it's converted to fat. So we can still, if we eat too many carbs, we can end up creating fat, and that's one of the things that many of us try and avoid. So we're going to end there with carbs, and we're going to talk, like I said, proteins, fats, minerals, and water.